Welcome back, 8th grade. So, we are in Chapter 2, Investigation 2, Section 1, and your sheet of paper looks like this in your packet. Draw as many squares as you can to fit in a 5 dot by 5 dot grid, which is a 4 space by 4 space grid. So, you have the obvious flat squares. So there's this one, and this is a 1 by 1, so that square area is 1. And then you have another obvious flat one. This is a 2 by 2, so this square area is 4. I'm just going to squeeze the 3 by 3 over here. With a square area of 9. And then the biggest flat square that you can fit is a 4 by 4, 4 spaces by 4 spaces, with a square area of 16. Now, you can draw some other squares. You can draw tilted squares as long as they have the same side length. It's a square and a 90-degree angle. So the most basic tilted square looks like this. So if you were to try to find the area of this square, you could break up the inside, and you would see that each of these are a half. So this square's area is 2. So the area would be 2 units squared. There's another way to find that square area. I'm just going to redraw that exact same square right here. And I know this is the same square because if you look at the outside, it's a 1 by 1. So this tilted diagonal length comes from this 1 by 1 triangle. And see how they're all 1 by 1s? And this is the other way to find this square's area, is to draw a box around it. So this box around is a 2 by 2. So the area of the box is 4. And then you're going to take away the 4 triangles, and they're all the same. The triangles are the same area. And these triangles are a 1 by 1. So area of a triangle is base times height divided by 2. So 1 times 1 divided by 2 is 1/2. So these are each 1/2. 4 halves is 2. So the area is 2. So go ahead and pause and see what other squares you can come up with. Pause. Okay, so other tilted squares, you might have found the tilted square that results from a 1 by 2 triangle. So see how I went over 1, down 2? I would actually just continue that pattern. So over 1, down 2. You're alternating between a 1 and a 2 and a 1 and a 2. So over 1, down 2. If you twist your paper, it would keep being over 1, down 2. And then 1 by 2. So that's a perfect square from a 1 by 2. Now there's the 2 ways to find the area of this square. One is to break up the inside. So these triangles are a 1 by 2. So each of these triangles that are a 1 by 2, 1 times 2 is 2, divided by 2 is 1. So the area is 1. And the square in the middle has an area of 1. So this area is 5 units squared. So this triangle resulted from a 1 by 1, or the square I should say. This square's side length resulted from a 1 by 2. We could also do a 2 by 2. So this is over 2, up 2. So we're going to just continue that pattern. So over 2, up 2, over 2, up 2. And then actually the last one's already drawn for us. We can continue the over 2 up 2. If you'll notice the exterior, every single side length has a blue and a red. So you can break this up in the middle. This is kind of an easy one to break up in the middle because like this, each of these triangles are a 2 by 2. So each triangle is 2. So the area is 8. But you can also break it up on the outside. So the outer box is a 4 by 4. So 4 times 4 is 16. And then each of these triangles are 2 by 2s. This is 2 and this is 2. So each of these triangles, the area of the triangle is 2 times 2 divided by 2, which is 2. So this is also 8 that we're taking away. So we've taken away all the black business, and we're left over with 8 units squared. So we have our 1 by 1. We have our 1 by 2. We have a 2 by 2. What about a 1 by 3? So let's continue that pattern. 1 by 3. So 1 by 3. One by 3. And then 1 by 3. So each outside has the blue and the red perfectly. We've continued the 1 by 3 pattern. We know that the diagonals are all the same because they all drop a triangle that's a 3 by 1. So that's how we know this is a square. So one way to find the area is to break up the inside. So this would be a 1, 2, 3 by 1 triangle. That's 1.5. This would be a 1, 2, 3 by 1 triangle. That's 1.5. This is a 1, 2, 3 by 1 triangle. That's 1.5. This one's the same thing. And the middle box is 4. So this is 3 and 3, which is 6, plus 4 is 10. The other ways to do the box around the outside, this one's a 4 by 4. So that'd be 16, minus each of these triangles are a 3 by 1, which we already know is 1.5. So when you take away the 6, because 4 1.5s make 6, you also get 10. So we have the 1 by 1, the 1 by 2, the 1 by 3, and a 1 by 4 will also fit. I'll make that 2 colors. Oh, I guess it won't, will it? You would think it would. Because why this won't fit is that you're going to need another space to get that off. See, it'll go off right there. I'm just going to erase this whole thing. So a 1 by 4 will not fit because a 1 by 4 is like this. And then to get the next one, you've got to go off. So a 1 by 3 is the biggest that will fit. Then we've got our 2's. So a 2 by 1 is already drawn right here. You've got a 2 by 2, so a 2 by 3 should fit. So 3 by 2. And that will not fit. Okay, so you have your 1 by 1, your 1 by 2, your 1 by 3, and your 2 by 2. Nothing else will fit because they'll be too big. See how this one kind of fills up the whole thing? If you tried to do like a 3 by 2, 1, 2, 3 by 1, 2, it's going to end up going off the grid because your 3 is already off the grid. So that's it for the squares that will fit. Now we're going to talk about the side length that these squares give us. So a 1 by 1 square gives us a side length of 1, which we already knew. Area of 4 square gives us 2. The area of 9 gives us 3. And the area of 16 gives us 4. What's special about these numbers is that they are perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So what's special about the big numbers is that the square root of 16 gives you 4, the square root of 9 gives you 3, the square root of 4 gives you 2, and the square root of 1 gives you 1. So these are all perfect square roots. So how do you suppose we would find the area of a tilted square that has an area of 2? Not the area, the side length. How do you propose we would find the side length of a tilted square that has an area of 2? Well, if something has an area of 16, you square root 16 and you get 4. If something has an area of 9, you square root 9 and you get 3. If something has an area of 4, you square root 4 and you get 2. If something has an area of 1, you square root 1 and you get 1. So if something has the area of 2, you square root 2 and you get 1.414 blah blah blah. This diagonal length is the square root of 2. It's a little bit more than 1 and a little bit less than 2. If you take a ruler and you measure this and you pick that up, I'm taking my fingers and picking it up, that mark goes from here to here. So this is the square root of 2. A diagonal length is not 1. They are not wholes. They are decimals. So if you have perfect centimeter ruler on a perfect centimeter paper and you can measure to this perfection, that's what you will get. So if you have a square that's tilted with an area of 5, that means the side length is the square root of 5. A tilted square with an area of 8 has a side length of the square root of 8, and a tilted square with an area of 10 has a side length. Every side length is the square root of 10. Every one of these diagonals is the square root of 10. So any triangle that is a 3 by 1 has the diagonal length of square root of 10. You basically, this is called the hypotenuse. So if you have a 3 by 1 triangle, you have this diagonal length, you could literally draw a box, find the area, and take the square root. All right, I hope that makes some amazing sense. We're going to pick up with this when I see you next. Have a lovely night.